discussion and a little Q&A after the webinar. And delivering our webinar today, welcome the very lovely Dr. Vanessa Kay. Vanessa's got a wealth of experience, not just as a Genstat user, but also as a developer and innovator. She's currently president of the Australasian region of the International Biometric Society. And on a more personal note, is a huge animal lover. You may see her dog popping up at point during the webinar. Bear with us, a lot of us are still working from home. Yeah, so with that, without further ado, I'm going to hand you over to Vanessa.
Thank you very much for that kind introduction, and welcome everyone to this demonstration of Genstat 22. So I'm just going to turn off my camera and share my screen so that you can enjoy Genstat 22. So hopefully you can see the Genstats start page. But yes, as I am absolutely thrilled to be introducing the 22nd edition of Genstat to you. This, our latest release offering, has a wealth of new and exciting enhancements and features, which you can learn more about in our What's New page, which is on the knowledge base, and you can access this directly from the start page in Genstat. So there are many new additions and improvements to Genstat 22. I'm not going to go through all of these, of course. I'm just going to focus on a few selected highlights. So let's get started. Well, one of the many exciting developments to Genstat 22 is the addition of equivalence, non-inferiority and non-superiority tests. Now, these are extremely useful tests when the aim of the study is to demonstrate that two treatments are effectively the same, or that one treatment is not inferior or not superior to another. So, for example, this could occur in a medical trial when the aim is to prove that a new drug is just as effective as a standard drug, or that the side effects of the new drug are no worse than the standard drug. So the new menus for t-tests and ANOVA make it extremely easy for us to perform these tests. So let's look at a wee example in Genstat using the ANOVA menus. But first up, I'm just going to open a data set, wheat trial GSH. And this data is from a plant breeding trial in which the yield of several different wheat cultivars are to be tested for equivalence against the industry standard blaze. So we just begin by performing our ANOVA as per usual. So I'm just going to open the general ANOVA menu, stats, analysis of variance, general. So our Y variate is yield. We have a single treatment term cultivar, and this is a randomised block design with the factor block giving our blocking structure. So after clicking run, the further output button becomes available. And in this menu is a new button for equivalence tests. Clicking on this opens a new menu for performing equivalence, non-inferiority and non-superiority tests for a selected term in your analysis of variance. In this example here, we've just got one treatment term in our ANOVA cultivar. So let's assess which cultivars are equivalent in terms of mean yield to the industry standard blaze, which we select as our control level from this drop down here. And we'll do this at the 95% level. So we'll define our equivalence range as the mean yields being within 1 unit of blaze by entering -1. So oh no, my keyboard's just stopped working. There we go. Sorry about that. -1 and 1 into the equivalence limits fields. And let's also output a graph giving the 95% confidence intervals for equivalence with the cultivar Blaze. And if we wish, of course, we can add in a title into this field here. So once we're happy with the settings we've picked, all we have to do is click Run, and I'll talk about this graph in a second, but first I would like to show the output for the equivalence tests, which is here. Now, under the null hypothesis for an equivalence test, the means are assumed not to be equivalent. That is, the difference in the means lies outside the range specified by the equivalence limits, here -1 to 1. So on the output, we can see that we have 3 cultivars with a p-value of less than 0.05, Encore, Victor, and Wanaka. So for these 3 cultivars, we can reject the null hypothesis and conclude that they have mean yields equivalent to that of Blaze. Now we've also got weak evidence of equivalence to Blaze for a couple of other cultivars, Flame and Resolve. So these have small p-values, but not quite as small as 0.05. Now this conclusion is also evident from that graph that popped up earlier. And we can see here that the 95% confidence intervals for equivalence to Blaze, for Encore, Wanaka, and Victor all lie within the equivalence limits, which are indicated by these red vertical bars. Now, these equivalence tests, as I mentioned, can easily be performed using the t-test menu as well. So if I open the t-test menu, notice that under type of tests, now we have the option in Genstat 22 of choosing equivalence, non-inferiority, and non-superiority. Moreover, you can actually use the procedure directly. If I go to the input window, we'll see that the procedure is called t-equivalence. So you can use t-equivalence directly to perform these tests using output from a different type of analysis. For example, a linear mixed model. So that brings me to the end of the first feature I want to demonstrate. Is there any questions before I move on to the next one?
Doesn't appear to be anything in the chat at the moment, Vanessa, so carry on and we can take questions going forward.
Excellent, no worries. So the next feature that I wanted to demonstrate today is the new Generalized linear mixed model facilities for displaying and saving output, plotting residuals, producing predictions, performing permutation tests for the fixed effects, and visualizing the fit of the model. So back in Genstat, I'm just going to open another example data set, actually one of Genstat's built-in data sets this time, Great Knot 2000. Okay, so this data is from a split plot canola trial of cultivars by fungicides. And our variable of interest is LM plants. This is the number of fungus-infected plants within a plot of 25 plants. And we're going to model this using a binomial GLMM and look at the new facilities that we have. So let's open the main GLMM menu and fit our model. So stats, mixed models, REML, generalized linear mixed model. So our response variable is LM plants. The fixed model is cultivar crossed by fungicide. And our random model, it's another split plot. It's a split plot design, so we've got blocks and we've got whole plot within block. The distribution is binomial. I'm going to use a logit link, and the binomial titles are given by the variate in plants. So in Genstat 22, the kind of the downstream GLMM menus have been considerably updated. And what you'll find, if you're familiar with the menus for GLM, that they are very similar to these. So for example, under the options menu, there are additional options for displaying output and also for controlling the model fitting process. There is also a considerably more extensive and save menu that enables you to save many features from your analysis. And we also have newly added predict and further output menus. So let's start by having a wee look at the further output menu. So under this menu, you can select additional items of output to display. You can also generate residual plots. So I'm just going to run with the defaults here. And we've got a plot of the standardized residuals based on all random terms for our model. You can also generate plots of the means from the further output menu. And again, I'm just going to run with the defaults. And what pops up is a plot of the fungicide by cultivar means, and we've got the average SED bar also plotted there. And furthermore, you can use the further output menu to generate separation plots. Once again, just going to simply run with the default settings. So this plot can be used to visualize the fit of your model. It shows the model's ability to predict successes, in this case in green, with high probability, and failures in pink with low probability. So in this example, the model is doing reasonably well, with failures in pink tending to be on the left side, that's the lower probability side, and successes in green tending to be on the right, the higher probability side. So also new to Genstat 22 and accessible via the further output menu are permutation tests for fixed effects. So a problem with GLMM analyses is that the estimates of the variance components are generally smaller than the true values. The wall tests for the fixed effects also suffer from this bias, and that their p-values may be too small. So therefore we need to be cautious when interpreting these p-values. And this is especially the case when analysing a small data set or binary data. The new permutation tests for fixed effects in Genstat 22 help overcome this problem by providing an alternative, more reliable way to assess the fixed effects. So let's perform a permutation test on the fixed effects in our model. But before clicking run, I'm going to enter block and whole plot within block into this field to ensure that the blocking structure of the randomized design is respected when randomly permuting the data. Now, after clicking run, we are going to have to wait a moment or two before the output appears, as it does take a wee while sometimes to run these permutation tests. We'll look at the status bar here. We see we're still being told that we're processing the tests. And here we go. So what does this tell us? Well, the permutation test indicate that there's no evidence of a cultivar by fungicide effect, but there does look like there's an overall effect of cultivar and an overall effect of fungicide. Okay, let's now have a quick look at the new predict menu for GLMMs. And once again, this is very similar to the predict menu for ordinary GLMs. So let's form some predictions of the fungicide by cultivar means. Down here I can pick what to output. Let's output a description of how the predictions are formed, along with the predictions themselves, and the standard errors. Using this menu, we can also generate a plot of the predicted means. So let's do that. I'm going to select fungicide as my factor for the x-axis, group by cultivar. And for a change, I'm going to select a line graph with the average standard error bar. Click OK and run, and the graph of the predicted cultivar by fungicide means pops up, and of course we get the output that we requested in the output window. So yeah, I hope you find this greater functionality for producing and displaying and saving output from your GLMM analysis extremely useful. And this brings me rather rapidly on to the next feature that I wanted to talk about today. And this is the ability to easily fit a linear mixed model to censored data and obtain well-behaved and reliable estimates of the treatment means. But before illustrating this, I'm just going to quickly restart my session to clear out all that old data, and I'm going to open a different example data set, oats censored. So during data collection, fixed threshold right and left censoring occurs when measurements cannot be taken above or below a certain bound. In this example here, the yields have been right censored at 130. That is, any true yield greater than or equal to 130 is censored. Now, to analyse the censored data, we can use the new linear mixed model with censoring menu, which is accessible via Stats, linear mixed model, REML, linear mixed models with censoring. And we begin by just filling in the Y-variate, fixed model and random model fields as we would for a usual linear mixed model REML analysis. So in this example, our Y-variate is yield RC. Our fixed model is nitrogen by variety. Our random model is actually another split plot design, one of my favourite types of design. So we've got blocks, whole plots within blocks, and for completeness, I'm going to add subplots within whole plots as well. Next, we need to supply the censoring information. So we use the radio buttons to indicate whether the data are left or right censored. In this example, measurements cannot be taken above 130, therefore the data is right censored. So we select the right direction. In the bound field, we need to give the bound above which our data is right censored. So this is 100. In the give initial values for censored Y field, we have the option of providing starting values for our censored observations. And this can be helpful for speeding up convergence, particularly if you have a large data set. However, as you'll see in a minute, if we just start at the default, which starts the censored values at the bound, it actually converges very, very quickly. We also have the option of supplying an indicator variable for censored observations. Now, this is essential if the censored observations are entered as missing values in the Y-variate. In our case, the censored values have been entered at the bound, so we do not need to supply a censoring indicator. And we also have the option of saving the predicted Y-variate as censoring indicator, and we can display this in a spreadsheet if we wish. Now, the output and fitting process is controlled via the options menu, and this has many of the same settings as the REML options menu does. So let's output a description of our model, the variance components, their predicted means, along with the standard error of the differences. a summary of the censoring and the wall tests. Once you're happy with the settings here, all you have to do is click OK and run, and the analysis is performed. So we see that the output is very similar to that of the usual REML analysis, except at the top we have some additional information related to the censoring. So the EM algorithm, which is used when fitting a linear mixed model to censored data, converged very quickly after just 10 iterations. And we can also see that 16.7% of the Y-variate values are right censored at 130. Below that is the REML output. And notice that our response variable is new yield RC, a variable not in the original data set. So what is this creature? Well, it's simply a copy of our response variable, which is yield RC, but with the censored observations replaced with their estimates. And finally, we have the usual save, further output, and predict menus as for a REML analysis. So that brings me now on to the next feature that I want to, sorry?
Hi Vanessa,
Hello.
we've got a question from MK. MK, I'm going to unmute you. You have to bear with us, guys. This is a new platform for us, the webinar. We're not wholly familiar with it, and I'm concerned that you aren't even able to post in the chat. So MK, bear with me. I'm unmuting you so you can raise your question. You'll have to unmute yourself as well. So your microphone's been unmuted, MK, but you need to, if you wish to talk, you need to unmute yourself as well. Okay, so I'm not sure if MK can hear me or is unable to unmute the microphone. Again, if you do have any questions, please post them in the chat, or we will come back to you at the end of the webinar. Thanks, Vanessa. Please carry on.
No worries. Okay, so that brings me to the next feature that I'd like to show you. And this is our new graphics menu for confidence region plots. And this enables us to draw 2D scatter plots with confidence, prediction, and or equal frequency ellipses superimposed. So back in Genstat, I'm just going to restart my session, so bear with me a second. I'm going to open another one of Genstat's built-in example data sets, the IRIS data set. And this is the very famous Fisher data set containing measurements of sepal and petal width and length on 3 different varieties of iris. And I'm going to use the confidence region plot to examine the relationship between sepal length and width. So let's open that menu now. So graphics, confidence region plot. So the data tab is exactly the same as for a 2D scatter plot. So let's select sepal length as our y-variate, sepal width as our x-variate, and species as our grouping factor. Now it's the option tab where things get more interesting, as it's here we can select the type of ellipses to plot. So confidence, prediction, or equal frequency. So what are these creatures? Well, assuming a bivariate normal distribution and, for example, at a probability level of 0.95, as is expected that 95% of confidence ellipses will contain the true bivariate mean, 95% of prediction ellipses will contain a future bivariate observation, and 95% of the observed data will be enclosed within the equal frequency ellipse. So let's add a 95% equal frequency ellipse to our scatter plot for each iris species, and we define the probability levels here. And in the options tab, we can also set a number of additional attributes to control the appearance of the graph. For example, we can add a title and control where it is positioned. We can also select additional items to display, so a key, the individual data points, and the principal axes of the ellipses. We can also specify the colours and the line styles used to draw the ellipses, and if selected, the principal axes. And we can choose whether to fill the ellipses with a transparent colour, and the level of transparency is set here. As for an ordinary 2D scatter plot, we can also control the appearance of the symbols used to plot the graph, the x-axis, the key, the x-axis, the y-axis, and the frame. So I leave pretty much all these at the default and click run, and our graph appears. So it's a scatter plot of sepal length against sepal width for the 3 different species of iris, and those lines are the principal axes for the ellipses. I guess from this graph we can see that the relationship and the variability around the relationship for setosa, which is plotted in blue here, is a bit different compared to those other 2 iris species. Anyway, I've just given a very, very brief overview of the new menu for confidence region plots. However, you can create a wide range of very beautiful and informative graphs using this menu, so please do have a play with it. Now, this brings me to the last feature that I wanted to demonstrate today, and this is our improved import options for Excel files. So here's an Excel file that I created earlier, and as you can see, it's got lots of colour, it's got a few different fonts, and there are also formulae embedded in the file. So Genstat has long been able to read in data from Excel using menus or the import command. However, cell colours could not be imported for display in the Genstat spreadsheet. And as we'll see in a minute, this is now possible in the 22nd edition. Furthermore, we can also import cell formatting information as data into a Genstat spreadsheet, such as font colours and styles or cell colours. Now, this is particularly useful when formatting cells has been used to capture some supplementary information, such as, for example, a cell being an outlier. And even furthermore, cell formulae can also be imported as data into Genstat. So let's see how. Back to Genstat, I'm going to open up my Excel file. Open. And you'll see now in the Excel import menu, there are additional options for what is written and what is displayed. So for example, we can select apply Excel cell colours to display the Excel cell colouring in our Genstat spreadsheet. So if I click finish, you'll see that I now have a brightly coloured Genstat spreadsheet matching the cell colouring of the original Excel file. Now, in this particular example, outliers and the live weight columns LWT1 to LWT8 have been coloured yellow. So we can read in the cell colour information from Excel into Genstat as data and use it to identify these outliers. So I'm just going to read in this data again. File, open, select the file I want. But instead of this time reading in the values, I'm going to read in the cell colours. Now next I am going to actually specify the range of data that I want to read in. So I only want to read in the cell colours from the live weight columns, which are in columns D to K. And I'm also actually going to omit the first row, which contains the variable names, because I don't want to overwrite my live weight variables. Click Finish and OK. And you'll see that a second spreadsheet has been generated, but this time containing the RGB values of the cell colours for the live weight variables. Now, for example, we can use this to replace the outliers in LWT4, which were indicated by yellow cell colour, with missing values using the information on cell colour that is stored in the variable C4. And I'm going to do this using the Calculate menu and the MV Insert function. Actually just going to grab the function from my clipboard just to save time and to ensure that I don't make a mistake. So what this formula does is it replaces the values in LWT4 with the missing values if the corresponding value in C4 is equal to the RGB value for yellow. And for the purpose of this demonstration, I'm actually going to overwrite the original variable. So if I click Run, you'll see that the yellow cells have now been replaced by missing values. And just a little bit of a further demonstration, I want to show you how you can replace all the outliers and all 8 live weight columns with a single calculation if we first create pointers for the live weights and colour information first. So I cheated and I prepared a little bit of code to create these pointers. The first one points to the live weight variables, the second one to the colour information. So I can run that code. And if we go to the Data tab under Pointers, you'll see now I've got these 2 pointers. And I can modify my function to operate on the pointers as so. And I'm going to once again actually overwrite my original data so you can see the effect. So if you click Run, we will receive a warning message telling us we're operating on multiple columns. That's okay, we know that, that's exactly what we want to do. Click OK, and now you'll see that all those yellow cells have been replaced by missing values. Yeah, well, so that kind of brings me to the end of this demo. Of a few of the highlights in Genstat 22, but there are many, many more new features and improvements which you can read about in the What's New page on the knowledge base, which you can access using the Start page in Genstat. So if you have any questions, please do type them in the chat. Or alternatively, you are welcome to contact me directly via email. It's vanessa@vsni.co.uk. And also, I'd love to hear any suggestions for new features in Genstat 23 or suggestions for improvements. So thank you all very much for your time, and I will stop sharing my screen now.
Thank you so much, Vanessa, for that wonderful demonstration.
Thank you.
We're going to go slightly off spec because we've got a little bit of time left. So Amy, I'm actually going to ask if you can enable everybody's microphone sometimes it's easier to verbally give these questions than it is to type in the chat. So Amy, if you can do that, if you can enable everyone's microphone, if you do have any questions, do please raise your hand. There's one of our guests, you've got the tag MK. Unfortunately, there's no other details on your name, and you've had your hand raised for several minutes now. You are enabled, so if you wish to talk, please go ahead. As I say, you must bear with us. It's I'm sure you all understand when you're webinaring on a new platform, there are sometimes some teething troubles.
I'll just mention that everyone's mic should be unmuted now, but to be able to speak, you need to then go into your settings and unmute your mic yourself.
Amy, sorry, but it looks to me as though people's mics aren't unmuted.
Okay.
Apart from MK, you're...
Those that have a question, please do raise your hands and then I'll come to you and unmute you directly.
We've got... Okay, great. Yeah, absolutely. There's going to be a copy of the a recording of this demonstration will be sent out to yourselves and everybody who's registered for this webinar. As we said earlier, please do feel free to share that amongst your team and amongst your colleagues. If you do have any specific questions that we're not able to answer today, as Vanessa says, we're happy to take them directly, or alternatively, you can email support@vsni.co.uk. Equally, if you know any questions about Genstat at all, if you're interested in a demo, if you're looking to purchase, again, contact us at support@vsni.co.uk.
Mike should be unmuted now.
Yes, okay, I can see that. Okay, so we've got two hands raised. We've got MK and Bob Noel Boniface. So what you need to do, guys, you need to unmute yourselves and then please feel free to go ahead and ask your questions. Hi. Who am I speaking to?
Look, this is Giri. I don't have any question, but it looks, I mean, it's very nice. It looks very interesting features, and especially the generalized linear mixed model part, and also the equivalence and superiority and inferiority test. Those will be very useful. So I would like to thank Vanessa for presenting very nice, clear presentation. So yeah.
Lovely. Thanks, Giri. Thanks for speaking and just confirming that people are able to speak on this webinar. As I say, initial teething troubles. Appreciate that. Anybody else? Any questions at this point? Okay. We've got. I know the name's Hebrew. Unfortunately, I can't read it, but you've got your hand raised. Please, you should be enabled. Please unmute yourself and feel free to ask a question.
Okay. Do you hear me?
Hello.
Yes, we can. Hello. Yes.
My name is Ido. And it is my daughter, so it's in Hebrew. My daughter teaches from school. Anyway, I have a suggestion, technical suggestion, that next, I hope you will continue with those meetings and webinars. And I think since it's probably new application for a few of us, like me, that at the beginning of every meeting, we will just practice like, hello, everybody will say, hello, it's me, you know, And then we will be sure that everybody know how to talk, how to ask questions, what is the rules. And so it will be much more dynamic and neutral conversation.
Thank you. Thank you. Great suggestion. We actually had quite a high number of registrations, which is why on this instance we thought it might be best not to get everybody to introduce themselves or say hello, but certainly something that we can consider going forward, and yeah, do a bit of a technical test up front and check people can post in the chat at the very least. Thank you for that. Appreciated.
Hello. Hello.
Hi.
Hello.
Who are we speaking to?
My name is Bumnoida Senga
Hi.
from Tanzania. I want to ask the requirements to purchase the Genstat 2022 edition.
Best if you and I can discuss this after. Genstat is sold on a tiered basis. We have different license types depending on what your requirements are. It also depends if you're working within a university, an NFP environment or a commercial environment. As I say, there's different tiered pricing. So I will contact you directly after this webinar, and we can further discuss the best options for you.
Okay, because I'm working on the research institution from Tanzania.
So yes, the research institution in Tanzania, yes?
Yes.
Yes, I will contact you straight after this webinar, Bob Noel, and we can discuss licensing and the best options for you.
Okay, thank you very much.
So we've still got MK with their hand raised. Disappointed not to hear the question because the hand was raised quite early in the webinar, but we will get back to you specifically. I'm hoping there's not been any technical issues that aren't allowing you to raise your question, but as I say, we'll get back to you all individually. We'll send the recording, and feel free to send questions and requirements direct to Vanessa or through to our support desk.
That'd be great.
I think that brings us to the end. Once again, thank you everybody for joining. Thank you, Vanessa, for another lovely demonstration. Yes, and hope we are in contact with you all in the future. I hope you enjoyed it, and thank you once again.
Thank you, Vanessa, and thank you, Kerry, and thank you all.
Thank you.
Wonderful.
Thanks so much.
Okay, see you at the next webinar. Bye-bye.
Bye.
Thank you.
Thank you.
Thanks, Vanessa. We're going to shut it down now. So
Yeah. Cool. Thank you.
feel free to sign out.
See ya.